From Cape Canaveral Air Force Station in Florida, you're watching live coverage of the launch of the SpaceX Falcon 9 rocket and Dragon capsule. This is Falcon launch control at T-minus 1 hour, 40 minutes and counting. Following the first Commercial Resupply Services mission to the International Space Station in October, SpaceX has prepared a new Falcon 9 and Dragon spacecraft, and as you see, they are poised for liftoff here at Cape Canaveral Air Force Station at 10:10 and 9 seconds a.m. Eastern Standard Time. The strong back has been rotated away from the rocket at Space Launch Complex 40. Everything is go technically, weather is go. This mission, designated SpaceX 2, is the second of at least 12 contracted flights by SpaceX to resupply the space station. Under the Commercial Resupply Services contract, SpaceX is restoring America's capability to deliver and return significant amounts of cargo, including science experiments and other materials, to and from the space station, which is a capability that was not available after the retirement of the space shuttle. The Dragon capsule is filled with more than 1,200 pounds of supplies, including critical materials that will support the 200 investigations planned for the station's Expedition 34 crew. Dragon will deliver 2 Glacier experiment sample freezers, 5 experiment sample cold bags, carbon dioxide removal assembly replacement beds, crew supplies, and spacewalking tools. And this will be the first SpaceX flight to carry external cargo to the space station. The Dragon will be carrying 2 heat rejection subsystem grapple bars that will be installed on the mobile base system of the space station. And later during a spacewalk, they will be moved to their appropriate locations. One major advantage to Dragon is that it comes back to Earth, and with it, it brings back vital experiment data. Dragon will be bringing back about 2,600 pounds of cargo, including 1 Glacier experiment sample freezer, scientific materials from human research, biotechnology, materials and education experiments, some failed space station hardware, crew items, trash, and 2 out-of-date and previously used carbon dioxide removal assembly beds. At the time of the launch, the International Space Station will be flying at an altitude of 253 miles out over the open Atlantic Ocean just east of the coast of New England. As we said, weather is looking good. There is an 80% chance of favorable weather for launch at 10:10 a.m. Eastern Time. Mike McAleenan, the launch weather officer from the U.S. Air Force 45th Weather Squadron here at Cape Canaveral Air Force Station, is briefing the launch director from time to time. The next scheduled weather briefing is at 9:10 a.m. Eastern Time, 1 hour from launch. Everything is looking good. There is an 80% chance of weather being go. The only 2 concerns are for liftoff winds exceeding 30 knots, and they are forecast to be below that. The forecast calls for 12 knots gusting to 20. The other item that is being watched is thick clouds that would have to be over the launch pad and the ascent path, and they would have to be at least 4,500 feet thick and extend into a region of clouds with freezing temperatures. And there is a forecast for a broken cloud deck at 14,000 feet that the weather team will be watching. But as it stands now, winds are light, 10 knots, peaking to 15 knots from the northwest, 300 degrees. We have scattered clouds at 4,000 feet. We do have a broken deck at 14,000 feet. And we remain 80% go for weather. So at this point, the Falcon 9 rocket and Dragon spacecraft are ready. There are no technical issues, and weather is go. At T-minus 1 hour, 35 minutes and counting, this is Falcon launch control. This is Falcon launch control at T-minus 1 hour, 32 minutes, 38 seconds and counting. It's a beautiful morning in Florida. The sun is rising over the Space Coast, and Falcon 9 and the Dragon spacecraft are poised for launch. We have an update to the exact launch time, required to launch to deliver the Dragon capsule to the International Space Station. The new launch time is 10:10 and 13 seconds a.m. Eastern Standard Time. Several months ago, both the Falcon 9 rocket stages and Dragon were transported to SpaceX's development facility in McGregor, Texas for testing, and then they were trucked individually to the SpaceX hangar at Space Launch Complex 40 here at Cape Canaveral, Florida. Here the stages were integrated and Dragon was loaded with its cargo. The final pre-flight test was a static fire when Falcon 9's 9 first-stage engines were ignited for a few seconds with the vehicle held securely to the pad, and that static fire was successfully accomplished on Monday of this week. Key NASA and SpaceX personnel have collaborated on the design of the rendezvous profile, including both the timing and the path of Dragon's approach to the International Space Station, and they've worked together to identify, process, and pack the NASA and international partner cargo that will be delivered to and from the station. A couple of weeks ago, on February 14th, a formal stage operations readiness review was conducted, and this involved representatives from SpaceX and all 5 of the space station's international partner agencies: NASA, the Canadian Space Agency, the European Space Agency, the Japan Aerospace Exploration Agency, and the Russian Federal Space Agency, Roscosmos, to ensure that the launch vehicle, the Dragon spacecraft, the cargo, the space station, and the launch and operations teams were ready for the mission. They sailed through that meeting, gave a go. Last night, the Falcon 9, after having been rolled out to the launch pad yesterday, was elevated to the vertical position. As you see, the strong back has been rotated away from the rocket. Falcon 9 and Dragon have both been powered up. Systems are activated. The computers are turned on. A little less than 4 hours before launch, the fueling process began, with liquid oxygen first, and then RP-1 propellant, which is a rocket-grade kerosene. Fueling operations proceeded normally. The plume that you see coming off Falcon 9 during the countdown is gaseous oxygen being vented from the tanks, which is why the liquid oxygen is being topped off throughout the countdown. At T-minus 10 minutes and 30 seconds, the terminal countdown will begin. At that point, all systems will be autonomous. And after polling Mission Control in Houston, Texas, and the launch team at SpaceX Mission Control in Hawthorne, California, the launch director will give a final go for launch at T-minus 2 minutes and 30 seconds. We're seeing views of the SpaceX Launch Control Center, where the launch today is being controlled. At T-minus 2 minutes, the Air Force Range Safety Officer will be confirming the physical safety of the launch area and the eastern range. And 1 minute before launch, the flight computer will be activated. 55 seconds before liftoff, the launch pad's water deluge system, which is dubbed Niagara, will be activated. It will suppress the acoustic waves that radiate from the engine plumes and counter the effect of the vibration of the rocket. There are 53 water nozzles set low on the launch pad that will provide a curtain of water flowing at 30,000 gallons a minute. Then 3 seconds before launch, the 9 Merlin engines of the first stage will ignite. And at T0, the rocket computer commands the launch mount to release the vehicle for flight, and Falcon 9 will lift off, putting out 855,000 pounds of thrust. That's a thumbnail sketch of what will occur between now and 10:10 and 13 seconds a.m. We are at T-minus 1 hour, 27 minutes, 40 seconds and counting. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 1 hour, 21 minutes, 57 seconds, and counting. And as we prepare for the launch of the SpaceX mission to the International Space Station this morning, NASA is also making steady progress toward our goals of returning human launches from U.S. soil. NASA's Commercial Crew Program is an innovative partnership to help the aerospace industry in the United States develop space transportation systems that can safely launch astronauts to the space station and other low Earth orbit destinations. The Commercial Crew Program is building on NASA's 50-year history of human spaceflight by developing a new transportation industry that's geared toward opening space travel up to more people than ever before. Using a non-traditional approach that features public partnerships, NASA is facilitating the development of several designs of spacecraft, enabling NASA to choose which ones it wants to use to send astronauts into space. And the end result could be multiple systems providing safe, reliable, and affordable access to space. The Commercial Crew Program is integrating industry's innovative capabilities to advanced technology with NASA's 5 decades of human spaceflight experience. And there are several aerospace companies starting programs aimed at fulfilling NASA's Commercial Crew Program goals. The Boeing company continues to develop its CST-100 spacecraft. The CST-100 is a reusable capsule-shaped spacecraft designed to take up to 7 people, or a combination of people and cargo, to low Earth orbit, including to the International Space Station. Boeing has designed its spacecraft to be compatible with a variety of expendable launch vehicles, and they've selected United Launch Alliance's Atlas V rocket for initial CST-100 flight tests. The Dream Chaser spacecraft from Sierra Nevada is a reusable lifting body spacecraft based on improvements of NASA's HL-20, which somewhat resembles NASA's space shuttles, and it boasts years of development, analysis, and wind tunnel testing by the Langley Research Center in Hampton, Virginia. Plans for the spacecraft include launching vertically and free flight capabilities in low Earth orbit to dock with the space station. Dream Chaser currently is the only commercial crew development round 2 vehicle that's being developed with wings and the ability to land on a conventional runway, such as the shuttle landing facility at Kennedy Space Center in Florida. And SpaceX has a reusable Dragon spacecraft designed to launch atop the company's Falcon 9 rocket, and it would be capable of carrying up to 7 astronauts to low Earth orbit. After a mission, Dragon would return to Earth's atmosphere with a parachute landing in the ocean, and the company also is working on ground landing capabilities for the future. The Dragon capsule currently is contracted to fly these 12 cargo-only missions to the space station for NASA's Commercial Resupply Services program, the second one today. And SpaceX's mission control will be at its headquarters facility in Hawthorne, California, while launches will take place right here from Space Launch Complex 40 at Cape Canaveral Air Force Station in Florida. So a lot of work underway, not only to deliver cargo to and from the International Space Station, but to re-equip America with the ability to send astronauts from U.S. soil back to the space station and other destinations in low Earth orbit. At T-minus 1 hour, 17 minutes, 44 seconds and counting, this is Falcon Launch Control. This is Falcon Launch Control at T-minus 1 hour, 14 minutes, 41 seconds and counting. The team here at the SpaceX Launch Control Center in Port Canaveral, Florida is working no technical issues at this time. Weather remains 80% go. Currently, all the weather criteria are green. And as we are getting ready for launch again this morning at 10:10 a.m., we wanted to also point out to you that NASA is making steady progress toward our other exploration goals. We have a video that highlights the progress being made by the Space Launch System, the Orion Multi-Purpose Crew Vehicle, and the Ground Systems Development and Operations Programs, the core elements of NASA's human space exploration architecture.
One small step for man, one giant leap for mankind.
This is Falcon launch control at T-minus 1 hour, 8 minutes, 50 seconds and counting. Back at Space Launch Complex 40 at Cape Canaveral Air Force Station, viewing the Falcon 9 rocket topped with the Dragon capsule. The vehicle is 157 feet tall, 12 feet in diameter. Its 9 first-stage Merlin engines will generate 855,000 pounds of thrust at liftoff this morning, rising to nearly 1 million pounds of thrust as it climbs up through the atmosphere. The Falcon rocket is named for the Millennium Falcon in the Star Wars movies. The number 9 refers to the 9 Merlin engines that power Falcon 9's first stage. Meanwhile, the Dragon spacecraft is 14.4 feet tall and 12 feet in diameter. Its trunk is 9.2 feet tall. And with the solar arrays fully extended, it measures 54 feet wide. And as we mentioned earlier, although this is a cargo resupply mission, Dragon was designed to carry crew, and SpaceX is working toward that goal. The Dragon was named for the fictional Puff the Magic Dragon after critics in 2002 deemed SpaceX's goals fantastical. But here we are today after a successful operational mission in October. This will be the second of 12 planned as part of the Commercial Resupply Services contract that SpaceX has with NASA. After liftoff at 10:10 and 13 seconds a.m., the first stage engine will burn for about 3 minutes. The spacecraft will separate, and the single engine second stage will burn, taking the spacecraft to its orbit, after which the solar arrays will deploy, and there will be a carefully choreographed series of thruster firings that will take the spacecraft to the International Space Station, where 6 crew members of Expedition 34 await its arrival tomorrow, Saturday. NASA television will begin coverage of grapple at 3:30 a.m. Eastern Time for an expected grapple at 6:30 a.m. All systems remain go. Weather is green, and at T-minus 1 hour, 6 minutes, 8 seconds and counting. This is Falcon launch control. This is Falcon Launch Control at T-minus 1 hour, 1 minute, 40 seconds and counting. And we're about 90 seconds away from a weather briefing by Launch Weather Officer Mike McAleenan from the 45th Weather Squadron here at Cape Canaveral Air Force Station. He'll be briefing the SpaceX launch team on the current conditions and the forecast for the remainder of the count. That will be at T-minus 60 minutes, exactly 1 hour from launch. And the next milestone after that, at about T-minus 40 minutes, we'll begin final vehicle configuration for launch. So once again, we'll stand by to listen to a weather briefing from Launch Weather Officer Mike McAleenan. This is Falcon Launch Control.
This is the LWO with the L-minus 1 hour range weather briefing. On your video display, you should have an enhanced infrared picture. This is also set up with a special enhancement to depict the cloud tops at 0 degrees Celsius at green, minus 10 degrees Celsius in orange, and minus 20 degrees Celsius in red. Anything showing up in green shows cloud tops that are in the threat range for triggered lightning if those clouds were indeed 4,500 foot thick. It also shows the corridor of travel for those clouds and timing at 3 hours, 2 hours, and 1 hour arcs. We are 1 hour out, so inside that 1 hour arc, you can see quite a bit of clear air or clouds lower than 0 degrees Celsius tops, and just some scattered conditions of 0 degrees Celsius tops, of which are less than 4,500 foot thick. Zooming in a little closer, you can see on visible that very thin, in-depth clouds moving over spaceport at this time. A little bit thicker clouds to the south associated with the jet stream, but all that is translating to the south, and we're looking pretty good for launch. Looking at the winds at the launch pad, currently at 10 knots with peaks to around 12 to 14, and that's expected to continue throughout the count and be a similar range for T0. Looking at upper level winds for the last 6 hours or so, you can see progressively weaker winds in the low levels, indicating with less than 30 knots earlier on in the count, and now down to 10 to 15 knots as we're seeing on the towers. But you can see an increase in wind speeds through time at the mid-levels between 10 and 15,000 feet, also between 25 and 30,000 feet, and above the peak winds of 125 knots between 40 and 50,000 feet. And we do expect that trend to continue, as indicated on our AMU upper-level wind tool. Using the model forecast from lighter color to darker color, you can see the model has forecast that trend to continue to increase in those levels between 30 and 40, and also between 40 and 50,000 feet through the window. Moving to our operations forecast today, we are still looking at few clouds at 4,000 feet and 14,000 feet. Good visibility. Winds will remain out of the northwest at 10 with peaks to around 15 knots, and we've gone with an overall probability of violation for those clouds of 10%. Currently, we are go on all weather constraints. If there were a problem and we needed to delay for 24 hours, forecast remains virtually the same with scattered conditions up through the mid-levels, winds between 12 peaking to 20 knots out of the northwest, and an overall probability of 20% chance of violation. So just to reiterate, we are go on all constraints, looking for some mid-level clouds moving over the launch complex that are of thickness that is not a concern for triggered lightning. Thank you. This concludes the range weather briefing, unless there are any questions.
And good news from Launch Weather Officer Mike McAleenan. We're go on all constraints. There are no concerns. Winds are low, and the clouds are not predicted to be thick enough to cause a problem at the time of liftoff. He has increased his probability of launching to 90%, and we are at T-minus 55 minutes, 40 seconds, and counting. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 49 minutes, 21 seconds and counting. And we are very pleased to be joined this morning by NASA's Deputy Administrator, Lori Garver. Good morning, Lori.
Good morning, Mike. It is great to be here.
It's great to have you here. This is another exciting day.
Indeed. We've been looking forward to yet another launch to the International Space Station, and looks like we're going to be ready to go here in under an hour.
Well, it's their second operational flight of a private company to attempt to berth with the International Space Station after the successful mission in October. And wondered if you could explain to us why these resupply missions are so important.
Well, you know, the International Space Station is the cornerstone of our human spaceflight program, and the space shuttle was able to build the space station, but now that we have really the need for just taking our crews and cargo to and from station without assembly, it's a lot more efficient for us to launch from the private sector, and this has been part of our plan for years. We are so excited that we've had a couple successful launches, and the SpaceX launch today is part of that longer-term program that keeps us not only spending less on low Earth orbit in order to service the space station, allows us to invest more in the deep space missions that NASA's really driving towards.
So that's part of how the commercial cargo and crew missions are fitting into the overall picture of what our future is for NASA.
Absolutely. Again, the cargo program's been a long time program. We knew with the shuttle retirement that we were going to need to find ways to go to the space station for less cost, and this is really going to help us. And this is really going to allow us to be able to reduce the cost of low Earth orbit for us.
Well, now that the International Space Station is built, and we have a team of 6 up there working around the clock 24/7, they're conducting microgravity research. Can you tell us why this type of research is so important?
Well, the space station is critical to us learning how humans live and work in space. Of course, we know as we go further, things will change in deep space, but having that microgravity experience is necessary for us to go further. So we're doing experiments, life sciences, things that affect the human body in space, and making sure that when our astronauts go out, they can be safe. But in addition, we're utilizing that microgravity environment to benefit us all here on Earth. So this launch and return in a couple weeks alone are giving us all kinds of scientific benefits, like research into the physical sciences, materials, combustion research, as well as life sciences. So it's an important time on station. It's a national laboratory. We are getting more and more science time of the astronauts as we streamline the operations of station, and that is going to allow us to really focus on exploration and discovery, those core tenets of NASA.
Well, now that we're really ramping up the research on the station, we have universities, private companies, and even school kids involved in the research. How is this going to improve life on Earth?
Well, we had, I just read, even 30,000 students who were working on some of these cooperative experiments on station, and so the world really is looking to us for leadership, and NASA continues to lead the world. We, on space station alone, are benefiting the health of us here on Earth through studies on how the body ages, osteoporosis, having the ability to test metabolites on human tissues so that we can advance the vaccine times for certification, working on a couple of those now with NIH and the private sector. The benefits of space station are across all of our science disciplines. However, we also have earth sciences experiments on space station, and I think ultimately the benefit is this cooperative research laboratory we have. So we're working with these 14 other nations peacefully in space, and the United States, of course, started our space program in competition with the Russians. And for us now to be working peacefully with them, in my view, you just can't put a price on the value that has been to us, to have astronauts and cosmonauts living and working in space. And as we understand what effects that has on humans, it allows us to go further. So we need space station, and we need these cargo flights to get us to and from station in advance of crew flights in a couple years with our U.S. partners in the private sector. So it's a plan that makes perfect sense. It's a plan that we're well on our way toward fulfilling, and today is is a key part of it, and we're really excited.
It truly is collaborative with all the international partners and now private industry working with NASA to benefit everybody on Earth.
Well, NASA's always worked with the private sector. 80% of our dollars have gone to industry since our very beginning, and partnering with the private sector in new ways to create even more jobs and more economic value is what this program is all about. NASA does it in other areas as well. We don't want the government to have to pay every dime of this program because we know our dimes are limited. We want to bring that innovative spirit from the private sector in so that they can open up new markets, reduce the cost, and allow us, in this case of a launch vehicle, for instance, to win back market share that the United States has lost to the Chinese, the Russians, and the French over the last 20 years. That's a hundreds of billions of dollar market that we have loss that will help us in untold ways if we can get the competition going in the United States to again be able to launch not only NASA, astronauts in the future, as well as cargo, but military spacecraft and ultimately commercial satellites as well.
Great. Well, thank you for taking time to come and share that with us this morning, and we will look forward to today's launch.
Great to be here. Go Falcon 9, go Dragon.
Very good. Thank you, Lori.
OSM, this is LC on the countdown net. OSM, LC, countdown net.
LC, this is OSM.
Yeah, OSM, verify flight hazard area roadblocks have been established.
Verified.
Copy.
Proceeding in the Yoda auto sequence. Print INAV command has been sent to the flight computer. TTEB vent auto is closing out. Dynamic status setup is running.
And that step is complete, VC.
Copy, proceeding. LC, if needed, direct RCO to coordinate a supplemental weather briefing on the UMetNet.
Stand by.
This is Falcon Launch Control at T-minus 34 minutes, 45 seconds and counting, and all continues to go well this morning for the countdown leading to liftoff of the SpaceX Falcon 9 rocket and Dragon spacecraft at 10:10 a.m. Eastern Standard Time from Space Launch Complex 40 at Cape Canaveral Air Force Station. And with the launch, the Dragon will arrive at the International Space Station tomorrow, Saturday. And we're looking at video from the SpaceX mission to the station in October as the Dragon capsule approached the International Space Station. This time it'll be the fastest U.S. spacecraft to rendezvous with the International Space Station from the time of launch to grapple. And NASA television coverage will begin at 3:30 a.m. Eastern Time tomorrow for an expected grapple at 6:30 a.m. Positioned at the Cupola workstation, Commander Kevin Ford and Flight Engineer Tom Marshburn will grapple the Dragon with the Canadarm2, as you see in this picture, the space station's robotic arm. And from there, the capsule will be moved to the pre-install position about 150 centimeters from the Earth-facing port of the space station's Harmony module. And then Mission Control in Houston will command the arm to berth Dragon. Once the Dragon capsule is attached to the space station, the crew will open the hatch to Dragon on Sunday at about 5 a.m. Eastern Time. The crew will then unpack all the hardware, science experiments, supplies, food, and everything contained in the Dragon capsule, and then they will pack it with items to return to Earth. And Dragon is scheduled to return on March 25th and splash down off the west coast of Baja, California. Again, weather is 90% favorable for liftoff. The teams are working no major issues at this time. This is Falcon Launch Control.
T-minus 30 minutes.
CE pole stations and report LCCs are ready for terminal count. Copy.
Okay, stations have been pulled and are ready to proceed into terminal count. We are watching a blue line on the flight computer against the cold temperature, but otherwise we're good to go.
Copy, proceeding. CE save current LCCs to disk.
And saved.
Copy, proceeding. LC execute final test launch preparations per 1.160.
That's complete. You can proceed.
Copy.
That's in work.
Proceeding.
This is Falcon Launch Control at T-minus 24 minutes, 56 seconds and counting. Everything is proceeding normally for the count toward liftoff of Falcon 9 and Dragon at 10:10 a.m. Eastern Time. Both the rocket and the spacecraft have been powered up. All the systems are activated. The computers are operating. Falcon 9 first and second stage engines are ready. The propellant tanks have been filled. We're about 5 minutes away from beginning the final launch countdown preparations. At T-minus 13 minutes, a readiness poll of all 14 console positions will be performed. The mission is being managed by the Launch Control Center here at Port Canaveral, the SpaceX Launch Control Center, which you're looking at right now. There also are teams standing by once Falcon 9 lifts off to monitor the flight at Mission Control Centers, the SpaceX Mission Control Center in Hawthorne, California. That's we're looking at a view there now of the SpaceX Mission Control. And of course, Mission Control in Houston will be monitoring the launch and the activity as Dragon proceeds toward the International Space Station. Weather is looking good. There are no violations of weather criteria at this time. Winds are from 300 degrees, the northwest at 10 knots, peaking to 10. There had been some concern about possible wind violation, but we would have to reach steady state winds of 30 knots for that to be a problem, and we don't foresee that happening today. And the clouds that were forecast to be a potential issue also are remaining thin enough that we don't expect there to be a problem. So at this point, everything is on target and looking good for T0 at 10:10 a.m. and 13 seconds Eastern Time. This is Falcon Launch Control. This is Falcon Launch Control, T-minus 18 minutes, 15 seconds and counting. Very quiet in the Launch Control Center firing room as all systems appear to be working normally. There are no technical issues at this time. The weather continues to be 90% go. This is Falcon Launch Control.
I'm at liftoff. Let's switch to pad net A to secure the pad.
Roger.
T-minus 15 minutes.
This is Falcon Launch Control.
Personnel stand by for the section 10.57 of procedure 1.160.
T-minus 13 minutes, 50 seconds and counting, and as you heard, at T-minus 13 minutes, we'll be standing by for the final readiness poll. All systems appear to be go, and based on that poll, we'll head toward the final portion of the countdown where we begin the auto sequence start at T-minus 10 minutes and 30 seconds.
All stations verify ready for launch. All stations acknowledge. FTS.
FTS go.
Prop.
Props go.
AVI.
AVI's go.
GNC.
GNCs go.
Ground.
Grounds go.
VC.
VCs go.
GC.
GCs go.
DC.
DCs go.
RC.
RC go.
OSM.
OSM go.
ROC.
Rock go.
CE.
Go.
LD.
LDs go.
MD.
Dragonus go.
LD. Verify go to initiate terminal count.
Proceed with terminal count.
This is Falcon Launch Control. T-minus 12 minutes, 20 seconds and counting. And as you hear, every position is go for launch. We're on target for a liftoff at 10:10 a.m. and 13 seconds Eastern Standard Time.
T-minus 12 minutes.
The Falcon 9 rocket and Dragon spacecraft will be on their way to the International Space Station, carrying more than 1,200 pounds of cargo, including science experiments and supplies to restock the International Space Station. The terminal countdown will be underway at T-minus 10 minutes, 30 seconds, about 1 minute from now.
VC, start the terminal count auto sequence, set to start at T-minus 10 minutes.
Copy. Terminal count launch has started.
If a hold is called from this point forward, the terminal count auto sequence will be aborted. Indicate an abort or hold condition by saying hold, hold, hold on the primary countdown net. In this event, the VC will immediately abort the auto sequence. The VC shall not abort the auto sequence after T-minus 10 seconds, and operators shall not call a hold after T-minus 30 seconds. If a hold is called, all operators proceed to the terminal count abort steps in section 10.59. Stand by to pick up the count at T-minus 10 minutes and counting on my mark. 3, 2, 1, mark. VC, verify the auto sequence has started.
Terminal count is verified.
RCO, confirm clock is counting.
Clock's counting.
GCVC, stand by on FireX.
Standing by.
Standing by.
RC, start the range video recorders.
Roger.
OSM, set launch enable to flight.
Switch to flight. Pre-valves coming open. Aux bleeds coming open and chill in first stage engines.
T-minus 9 minutes.
The 9 first-stage Merlin engines are being chilled for flight. T-minus 8 minutes, 45 seconds and counting. At T-minus 8 minutes, the Dragon will go to internal power. T-minus 7 minutes, 28 seconds and counting.
T-minus 7 minutes.
First stage fuel bleed. Vehicles in self-line.
The Dragon's flight computer has begun self-alignment.
T-minus 6 minutes.
S2 TVC bleed started.
T-minus 5 minutes.
GN2 loads closing out.
Standing by for Falcon 9, first and second stages transferred to internal power.
Falcon 9 is switching to internal power.
We're on internal power on stage 1 and 2.
Vehicle release auto sequence has started.
T-minus 4 minutes.
Stage 2 TVC motion started.
Ground T-tip system is setting up.
T-minus 3 minutes, 30 seconds and counting. About a minute away from the launch director verifying a go.
Stage 2 TVC motion looks good.
FTS is armed.
LOX load is closing out.
All fuel trim valves at flight position.
LD, verify go for launch.
All systems are go for launch. S2 heaters is closing out.
Rock, verify range, go.
Range green.
Everything is go at this time. T-minus 1 minute, 48 seconds and counting.
Helium inlet's closing out. Pre-valves coming open. Aux bleeds open for the final engine chill.
Good feedback on all pre-valves.
T-minus 1 minute.
Vehicles in startup.
Flight computers in control of the vehicle.
Helium checkout closing out. Tank press system setting up.
T-minus 30 seconds.
All tanks at pressure.
T-minus 20.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of the Falcon 9 rocket and Dragon. SpaceX continues America's mission to resupply the International Space Station from U.S. soil. Falcon 9 just passing through maximum dynamic pressure.
Vehicle remains on a nominal trajectory. Vehicle is 30 kilometers in altitude, velocity of 1 kilometer per second, and downrange distance of 23 kilometers. Vehicle remains on a nominal trajectory. Vehicle is 51 kilometers in altitude, velocity of 1.8 kilometers per second, and downrange distance of 59 kilometers.
Approaching MECO 1.
Standing by for main engine cutoff 1 at T minus, or at T plus 3 minutes.
Pass in MECO.
MECO 2, stage 1 shutdown.
Stage separation confirmed.
And we see stage separation. Standing by for the ignition of the second stage engine.
And back ignition confirmed.
The ignition confirmed. This will be a 6-minute burn that will bring Dragon into low Earth orbit. The single engine is producing 92,000 pounds of thrust. Standing by for nose cone jettison.
Second stage propulsion systems nominal.
Vehicle remains on a nominal trajectory. Vehicle is 148 kilometers in altitude, velocity of 3.2 kilometers per second, and downrange distance of 346 kilometers.
Second stage propellant utilization active.
The 6 members of the International Space Station crew awake and watching this on a feed being provided to them from Mission Control in Houston. Four minutes away from the planned shutoff.
Vehicle remains on a nominal trajectory. Vehicle is 182 kilometers in altitude, velocity of 4 kilometers per second, and downrange distance of 541 kilometers.
Second stage propulsion systems look good.
Power systems look nominal, and we have a good telemetry lock on stage 2.
Three minutes remaining in the second stage engine burn.
Vehicle is 200 kilometers in altitude, velocity of 4.6 kilometers per second, and downrange distance of 767 kilometers.
Second stage engine cutoff 2 minutes from now.
Vehicle remains on a nominal trajectory. Vehicle is 210 kilometers in altitude, velocity of 5.6 kilometers per second, and downrange distance of 1,080 kilometers. IMU and GPS look good. Vehicle is passing through the head-on gate.
Stage 2 propulsion systems continue to be nominal.
One minute away from second stage engine cutoff.
Vehicles and terminal guidance.
FTS is saved.
Standing by for second stage engine cutoff in 10 seconds.
MVAC shutdown confirmed.
Vehicle is orbital. Perigee 199 kilometers, apogee 323 kilometers, inclination 51.66 degrees.
Standing by for Dragon separation.
Cameras pointing forward. Dragon set commanded.
And the Dragon has separated from the second stage. About a minute and a half away from the solar array deploy. And high fives all around the Launch Control Center, the SpaceX Launch Control Center at Port Canaveral, Florida. 1 minute from solar array deploy. Flight controllers at Mission Control Center in Hawthorne, California, watching the flight of Dragon. We're 10 seconds away from the start of solar array deploy. And as flight controllers in Hawthorne, California watch the progress of Dragon, we have launch replays of the successful launch of Falcon 9 that we would like to show you.
AOS Oak Hangar. LC, this OSM. Yeah, I just wanted to let you know they've got a couple of small fires outside.